So, I have a scary looking problem for us, but it's not as bad as it seems. So, we're given that sound dissipates exponentially with distance d from the source, according to this formula. Be important for whenever we solve it. So, basically, we can figure out what all this means, right? Putting this in the proper form is what is necessary for us to solve this problem. So, first, let's do that. So, this is the end, right? This is the end sound level, right? Like in PA. So the ending PA is the original times e to the power of the inverse or negative d divided by 6. So let's just rewrite the formula over here. P equals original, I'm going to rewrite it with O, times e, I don't really need to do the parentheses there, but to the power of negative d over 6. So knowing that, let's look at the problem. Don yells at point 0.2 PA, and Henry just barely hears him. Assuming the threshold for human hearing is that, how far away is Henry from Don? So the end sound level is this right here. This is the end result. So it's 9.8 times 10 to the negative 13th. So we're having to find, and the original is 0.2, it looks like. That's what he yells at. And then, of course, we have all the sound and whatnot, right? And using our formula, we're going to have negative x be our, we're going to have x stand for distance, So really it should just be this easy. And it looks like, if I'm not mistaken, 156 should be a right answer, which it is. You could have solved it algebraically, which I'll show in a second, by just simply dividing by O. So we would have the end result divided by, let me do this actually. Yeah, we've had the end result, which is 9.8 times 10 to the negative 13th. We would have divided that by 0.2. It's the same as like multiplying by 5. And then we would have been left with e to the power of negative d over 6 equal to this number right here, right? 4.9 times 10 to the negative 12th. Well, from here, this is just a simply logarithm, right? So we're having to figure out what power that e needs to equal this. So it's just the natural log of 4.9 times 10 to the negative 12th. I should probably put parentheses right here, just to clarify that's all in the natural log. And then that equals negative d divided by 6. And then you could multiply each side by 6 to cancel that out, and then switch the sign. So it's 6 times the natural log of 4.9. Sorry, I meant negative 6. Negative 6 times the natural log of 4.9 times 10 to the negative 12th. And you'll get 156 that way as well. So really it seems scary, but in all reality it's not a hard problem at all. But I just wanted to show that off.